dear class 12 students, welcome to one shot of probability for KEAM preparation. Well, as you guys know, there are only 30 days left for our KEAM exam, right? And I am Sana Khan, your new maths master teacher, and I will be doing a crash course on class 11th and class 12th mathematics course for your KEAM preparation. All right. So let's start with probability chapter first, because you know what? There are 8 to 9 questions asked every year in KEAM exam from probability itself, which can give you 32 to 36 marks. How good is that, right? So today I am going to revise each and every topic with questions for all of you, and we will also do previous year questions for KEAM exam which were asked previously in 2022, 21, 20 and so on, right? So we'll be practicing questions as well as revising the topics from the entire chapter. So are you guys excited? Let me know in the chat box. And yeah, if you are super duper excited, then show the Josh on the like button. Also, don't forget to subscribe to the channel, because you are going to get physics, chemistry and maths complete preparation for KEAM exam just on this channel and nowhere else. So do subscribe. Okay, so let's start with what is probability and why are we learning probability? Alright, now probability basically tells you the chance of happening of something. For example, will it rain tomorrow? Will Rajasthan Royals win the IPL match this year? So something like that is basically probability when we represent it mathematically, right? Now, if you want to learn probability, you should know some basic terms related to it, right? For example, whenever we say the event of happening of something, the outcome of an event, the sample space, what do we mean by that? So, let's take an example. Suppose we are rolling a dice, okay? Yeah, suppose we are rolling a dice, then when you roll the dice, what comes out? A number will come out, either 1 or 2 or 3 or 4 or 5 or 6, right? Now, what is this? These numbers are nothing but the outcomes of the experiment. So, what is your experiment? Rolling of dice is your experiment. What is the outcome? Whatever result you are getting, for example, 1, 2, 3, 4, 5, 6, this is your outcome, right? Now, when we say a sample space of an event or an experiment, what do we refer to? Just now we have seen that when I roll a dice, I get numbers. Now, the set of these numbers, do you guys know set? We have learned sets chapter, relations and functions chapter. So, set is a collection of something. So, the collection of outcome is nothing but your sample space. When you talk about probability of happening of something, you should know that it will happen out of what? Like, if you want to know what is the chance of getting a 6 on a dice, so you should know what are the other possibilities, what are the total outcomes possible, right? So therefore we need the sample space. And lastly, the most important term is the event. Now, what is an event? Event is basically a subset of the sample space. Example, just now I told you that what is the chance of happening of 6 on a dice, or what is the chance of head on a coin toss. So basically, event is basically occurrence of head in a coin toss. So when we are specifically talking about an outcome, a result, then that specific outcome is called the event. Alright, understood? I have given examples. Now let's see the formula for calculating probability, because this basic formula is used at a lot of questions which you will see in the previous year questions of KEAM. Okay, so let's say that A is an event in the sample space S, okay? Now, the probability of the happening of event A will be denoted by P of A, and the formula says number of favorable outcomes for A event out of total number of outcomes. Okay, so you might have a set of favorable outcomes. For example, again, if you toss a coin, so either head will come or a tail will come. So what is the favorable outcome for head? There is only one possible favorable outcome because only one time the head can come. But what is the total number of outcomes? 1 plus 1. Total number of outcomes are 2. So the probability of getting a head will be 1 by 2. Clear to all of you? Okay. Now, let's see some more formulas related to probability. Probability is basically number of favorable outcomes for the happening of the event E upon total possible outcomes. Probability of event A or B. So, what is or B? That either this will happen or this will happen. It is calculated with the help of this formula, which is known as A union B. And what is the formula for A union B? Probability of A plus probability of B minus probability of A intersection B. You should remember this formula. It is asked in a lot of questions. Okay. Next, again an important formula. What is the probability of not A? For example, if I tell you that the chance of getting a red ball out of a bag is 3 out of 8. What is the chance of not getting a red ball? Not getting red ball. So I know the probability of getting a red ball is 3 by 8. But I want to know probability of not getting a red ball. So what I will do? I will simply subtract it from 1. So 1 minus 3 by 8 will be 5 by 8. So the probability of not getting a red ball will be 5 by 8. So like that we calculate not A event probability. Clear to all of you? Now basically till now we have seen what is probability, some basic formulas related to probability and the basic terminologies related to probability. Now in the further chapter, what all things am I going to teach you? First we will learn the different types of event, because do you know there are a lot of possibilities of events and based on that their probability formula also changes. So we will learn about different types of events. Then we will learn about Bayes theorem and total probability and multiplication theorem, because these theorems are highly used in solving some complex problems. Alright, so let's first start with the different types of events that we have. Number 1, impossible event. What does the name suggest? Impossible to happen. Okay, so any event that is impossible to happen, can you name any? There are so many examples. For example, don't say that RCB winning an IPL is an impossible event. It has been impossible from the past 9 to 10 years, but you never know, right? But yeah, one sure short example of impossible event will be rolling a dice and getting 8. Is it possible? No, a dice only has 1, 2, 3, 4, 5, 6. How can you get 8 when it is not even written on the dice? So it is impossible. Similarly, sure event, 100% possible. So 100% possible is like there is a bag, it contains red ball, red ball, red ball, red ball. So if I ask you, what is the probability of getting a red ball? There is 100% chance of getting a red ball because there is no other ball, no black ball, no blue ball, no green ball. There are only red balls. So obviously you will get a red ball. That is the sure event, right? Next you have mutually exclusive events. Now mutually exclusive events are the events that cannot happen together. For example, very simple example is, suppose I say event A is getting a head of a coin, event B is getting a tail of a coin. You are tossing a coin. Is it possible that you get head and tail together? No, it's not possible. No such coin is made with head and tail together. Either you will get head or you will get tail. So they are what? Mutually exclusive of each other. They cannot occur simultaneously. They cannot happen together. Okay? If A happens, B cannot happen. Okay. Similarly, if B happens, A cannot happen at all. So they are mutually exclusive events. For example, if I tell you right at 10:30, you have to turn left, you have to turn right. Is that possible that you turn left and right together at the same time? You cannot do that. You cannot turn to left and right together at the same time at the exact moments. You will take at least 1 second time to just go left and right, right? So they are mutually exclusive events. Alright, next we have exhaustive events. Now exhaustive events are what? Suppose you have a sample space. Sample space. Inside the sample space, you have a lot of events happening. Event E1 is happening, E2 is happening, E3 is happening, E4 is happening, and so on. Lot of other events are happening. Okay. Now, when we look into the sample space, we see that some or the other event is going to happen when we select this sample space. So, such events are called as exhaustive events. So, at least one of them is sure to happen. For example, if you roll a dice, then probability of 1, probability of 2, probability of 3, probability of 4, probability of 5, probability of 6. They are all exhaustive events. Why they are exhaustive? Because one of them will definitely come. If you roll a dice, either one will come, or 2 or 3 or 4 or 5 or 6. One of them has to come. It is not possible that nothing is coming. 1 is also not coming, 6 is also not coming, 2 is also not coming, 3. It's not possible. One of them will come. So at least one of them is sure to happen. They are exhaustive events, right? Okay, so these were some typical type of events. We are also going to learn about independent events, but before that, we need to understand one very important probability called as conditional probability. Okay, now what is conditional probability? It is basically calculating probability for the occurrence of event A when event B has already happened. What does that mean? Suppose I have a bag. Inside that bag, I have a red ball, another red ball. I have a blue ball, and again blue ball, and again red ball. Okay? And if I tell you that I am taking out a ball, and then again I am taking out another ball. Okay? And if I ask you that I am not replacing the balls, I am not putting the balls back. I am taking one out and then I am taking the second one out. Okay. So, if I ask you what is the probability of getting a blue in second chance? Now, getting a blue in the second chance will be affected by getting a blue in the first chance? Yes. Why? Because in the first chance, getting a blue is basically 2 blue balls. There are 2 blue balls out of 5 balls. Now, in the second chance, again you want to get a blue ball. But now, 1 blue ball is already outside. So, how many remaining blue ball? Only 1 is remaining. Hai na? So, now when you calculate the chance of getting a blue ball, it will be 1 out of 4. Only 4 balls are remaining. 1 blue ball has already gone out. So, inside there are only 4 balls. So, the probability of this is depending on this. Hai na? Probability of second event is depending on the first event. That is conditional probability. Everybody understood what is conditional probability? I hope so. Okay. Now we have a formula for conditional probability. It says that the probability of happening of event A when event B has already happened. Taking out a blue ball when already a blue ball is already taken out. So, probability of happening of event A when B has already happened is probability of A intersection B upon probability of B. This is the formula for conditional probability. Okay, we'll see questions based on that. Don't worry. Now, there are some properties related to conditional probability. Number 1, if you have a sample space and event A, event B belong to the sample space. So what will be the conditional probability of happening of sample space when B has occurred? Super simple. We know that probability of A given B, an event given another event has occurred. What is the formula? Probability of event first event intersection second event divided by probability of second event. Now you tell me what will be the common between sample space and event B? There is an outer circle, there is an inner circle. What is common between them? This inner circle is common between them, right? This inner circle is common between the outer circle and the inner circle. So, probability of S intersection B will be nothing but probability of B upon probability of B. Cancel, we get 1. So, it is always 1. Hence proved, right? Second property, important property. If A and B are two events of a sample space and F is an event such that probability of F is not equal to 0, then we say that probability of A union B given F. We just wrote down the formula of A union B. Do you remember what was the formula of A union B? A union B is equal to probability of A plus probability of B minus probability of A intersection B. Same thing we'll do here. What has changed is here we are doing conditional probability given F. So everywhere you put given F, okay. So probability of A given F plus probability of B given F minus probability of A intersection B given F. So this is the formula. Just we are putting given F in this formula, okay. Now I will also show you a question where this formula will be used, so don't worry. Next, the last property is probability of E naught given F. Again, what is E naught? Not E is basically 1 minus probability of E. So similarly here, probability of not happening of E given that event F has occurred is 1 minus probability of event E given F. Cool. Should we do some questions based on these formulas? Because I know lot of formulas have been built up in the mind. Let's solve some questions for your better understanding. Okay. Now, in the question, what they have given? They have given 2 times probability of A is equal to probability of B is equal to 5 by 13. So, if 2 times probability of A is 5 by 13, this implies that probability of A will be 5 by 13 into 2. This 2 will go to the denominator. So, it will be 5 by 26. Okay. Now, they have given you probability of A given B is 2 by 5. They are asking A union B. So, let's do step by step. Probability of A given B. Conditional probability. This is what? Conditional probability. What is the formula for conditional probability? So, you have probability of A given B is equal to probability of A intersection B upon probability of B. This is the formula we have learned for conditional probability. Let's put everything in the formula. So 2 by 5 is equal to probability of A intersection B because we don't know what this is upon probability of B. What is probability of B? 5 by 13. Solve it. So you will get probability of A intersection B is equal to 2 by 5 into 5 by 13. 5 cancel, you get 2 by 13. Now, but they are asking you A union B. They are not asking A intersection B. But that's fine. We know the formula of A union B. A union B is what? Probability of A plus probability of B minus probability of A intersection B. Probability of A 5 by 26. Probability of B 5 by 13. A intersection B just now we calculated 2 by 13. Take out LCM and solve. So LCM will be 26, right? So this will be 10 by 13. This will be 10 by 26. This will be 4 by 26. I am just taking LCM of the denominator, right? So 5 plus 10, 15. 15 minus 4, 11. So this is 11 out of 26. Clear to all of you? How to get A union B? First, we will find out A intersection B, because A intersection B will give us A union B, and A union B is asked in the question. Clear how we are using all these values given in the question and conditional probability formula. This is conditional probability, hai na? This formula is for conditional probability, this one. Okay, chalo. Next comes a very important theorem, highly used in the entire chapter, which is multiplication theorem. It's super important. What does multiplication theorem say? Now this is very interesting, very logical theorem. Okay, for example, if I say there is a deck of cards. You all have seen deck of cards. There will be king, queen, ace, 2, 3, 4, 5, 6, 7, 8, J, right? So, deck of cards contain 52 cards. If I tell you, I am taking out one card, okay? Now, this card is basically a king. Again, I want to take out another card, which is ace. What is the probability? What is the probability of this? Now, how will you calculate that? See, here, both the event depend on each other. How they depend on each other? Because if you are taking out a king, the probability is there are 4 king out of 52 cards. But when you take out ace, it will be 4 out of 51 card, because one card is already taken out, na? So only 51 are left. So you want to know the probability of this and this, king and ace, because in the question it is written, in the first chance you should get king, it is compulsory. In the second chance you should get ace, it is compulsory. So when it is compulsory, this and this, hai na? The keyword here is and. So whenever you see and, you know you have to multiply. So it will be 4 out of 52 into 4 out of 51. That's the basic logic behind multiplication theorem. Now there is also a formula for multiplication theorem, which is nothing but conditional probability formula. So A intersection B. Why intersection? Because both are compulsory. A should also happen, B should also happen. So this is equal to probability of A given B into probability of B. How this formula came, I'll show you with an example. Okay, this is like very simple. I'm telling you probability of getting an ace when king has already been taken out multiplied by probability of king. That's what we are doing here, na? This is probability of king, this is probability of ace when king has already been taken out. King is already been taken out. So that's the probability of multiplication theorem. Let's do a question. 3 cards are drawn successively without replacement. Without replacement, you take out one card, then you are taking out another card, then you are taking out another card. You are not putting back anything. You are not putting anything back. Okay, you are just taking out, taking out, taking out. Okay. So 3 cards are drawn successively without replacement from a pack of 52 well shuffled cards. What is the probability that the first 2 cards are king and the third card drawn is an ace? First, king should come. Second, king only should come. Third, ace should come. It is compulsory. It is written. First 2 cards are king, third card is an ace. It is compulsory. Queen cannot come. Joker cannot come. 2, 3, 4 cannot come. Okay. So what will be the probability? Simple. So the final probability, the total probability will be probability of getting a king in the first chance. In the first chance. In the second chance, you should get again king, given that king has already been taken out. In the first chance, king is already taken out. In the third chance, you should get ace, given that 2 kings are already out. Given that 2 kings are already out. So what will be the probability? How many kings you have? You have 4 kings out of 52 cards. Next. Now how many king you have? You have only 3 king, because 1 king is out, thrown out. How many cards you have? Only 51. From 52 it will become 51. multiplied by. How many A's you have? You have 4 A's. A. Club, spade, diamond. You have 4 A cards out of 50, because from 52 it will become 51. From 51 it will become 50. One card is taken out. So like this we calculate total probability. This will be your answer. I am not solving it. You can solve it on your own. It's just simple multiplication. I'm sure you can do that. So just multiply, you'll get the final answer. Alright, understood how we apply multiplication theorem. It's more about logic than solving it. Okay, it's more about logic here. Clear to all of you? Okay. Now coming to very important type of event known as independent event. From the name itself you can tell what are independent events. So an event that does not depend on other event is called an independent event. For example, rolling a dice, tossing a coin. So rolling a dice, tossing a coin are absolutely independent of each other. They do not depend upon each other. If one is happening, the other can happen. If this is happening, that can happen. Now, two events E and F are said to be independent if probability of E intersection F is equal to probability of E into probability of F. Okay. So, if they are independent events, probability of E intersection F will be probability of E into probability of F. Now, will the conditional probability change if it is independent event? Yes. Since in independent event, let's calculate conditional probability. So, probability of F given E is probability of F intersection E upon probability of E. Now, we know that F intersection E is nothing but probability of F into probability of E. Just now we have seen that in the independent events, E intersection F will be E into F. We are just putting it over here. This is probability of E. Cancel. We get probability of F. So, conditional probability will be just probability of F if it is an independent event. Okay, let's do some question based on this. So, before that, let's discuss once again what are independent events and what are mutually exclusive events. So, independent events, two events which are happening at the same time but do not depend on each other. Rolling a dice, tossing a coin. They can happen at the same time but they do not depend on each other. Here, probability of A intersection B will be probability of A into probability of B. Mutually exclusive events, that if one event is happening, the other cannot happen. For example, tossing a coin, head comes out. So, if head is coming out, can tail come? No, it is head. Head will be called as head. It cannot be called as tail. So, mutually exclusive is two things which cannot happen at the same time. So, what will be their intersection? Can you take a guess? They cannot happen together. So, will they have anything in common? No. So, it will be 0. So, A intersection B is 0 for mutually exclusive event. Let's do a question based on this. Given that there are two events A and B, probability of A is given, A union B is given, probability of B is given as P. Find out the value of P if they are mutually exclusive and if they are independent. So, first of all, if they are mutually exclusive, that means probability of A intersection B will be 0. So, probability of A union B, what is the formula? Probability of A plus probability of B minus probability of A intersection B. Probability of A union B, 3 by 5. Probability of A, 1 by 2. Probability of B is P. A intersection B is 0. So, we get 3 by 5 minus 1 by 2 is equal to P. So, we get 3 2s are 6, 5 1s are 5, 6 minus 5 is 1, so 1 by 10. So, this implies that P is equal to 1 by 10. That's your answer. Second, if they are independent, what will happen if they are independent? If they are independent, then Probability of A intersection B is what? Intersection is nothing but probability of A into probability of B. So this is basically 1 by 2 into P, है ना? A is 1 by 2, B is P. So now let's calculate A union B is equal to probability of A plus probability of B minus probability of A intersection B. A union B 3 by 5, probability of A 1 by 2, probability of B is P, A intersection B is P by 2, है ना? We calculated P by 2 here, putting it here. So we have 3 by 5 minus 1 by 2 is P minus P by 2. P minus P by 2 is P by 2. 1 minus half is half, है ना? So we get P by 2 is equal to 1 by 10. So this implies that P is equal to 1 by 5. So here you are getting 1 by 10. Here you are getting 1 by 5 because one is mutually exclusive, one is independent even. Understood? Clear to all of you? Okay. Moving on. Next we have last two concepts of probability. Very, very important concepts used for solving big word problems. So there are chances they might not be asked in KEAM, but I'm still teaching you because they are there in NCERT and KEAM exam is kind of based on NCERT, so it might come, है ना? So let's learn about that. Okay, in short. So what is total probability? Simple. If there is a sample space and there are lot of events happening, event 1, 2, 3, 4, 5, 6, lot of events are happening, and you want to calculate the event of happening of A. Now A is depending. It is depending on E2, E3, E4, E5, E6. It depends on all of them. So what will be the probability of A? Probability of A will be A depending on E1 multiplied with E1. A depending on E2 multiplied with E2. A depending on E3 multiplied with E3 and so on. That is total probability. Clear? Let's do a question based on that. Suppose that 5 men out of 100 and 25 women out of 1000 are good orators. Assuming that there are equal number of men and women, find the probability of choosing a good orator. So, how total probability will be used? I want a good orator. Now, a good orator can be a man orator or a woman orator. So, I need total probability. Probability of man orator and probability of woman orator. So I need total probability here. That's why I will use the formula of total probability. So let E1 is the event of choosing a man, E2 be the event of choosing a woman, and A be the event of choosing a good orator. So what is the probability of choosing a man? Half. 1 by 2. Why? Because it is written there are equal number of men and women. So half men, half women. 50% men, 50% women. Similarly, probability of choosing a woman will be half because again there are half men, half women. Now, what is the probability of choosing a good orator? So, A is the choosing good orator given that it is a man. A good orator who is a man. How many are there? 5 out of 100. So, 5 out of 100. Similarly, probability of choosing a good orator given that it is a woman. An orator who is also a woman. How many? 25 out of 1000. It is given in the question. 25 out of 1000. Now simply I will use the formula of total probability. So the total probability of choosing a good orator is probability of choosing a man into probability of choosing a good orator who is a man plus probability of choosing a woman into probability of choosing a good orator who is a woman. Like that you get total probability. So here you have half into 5 out of 100 plus half into 25 out of 1000. Now just solve this and you'll get total probability of a good orator. That's your answer. Clear to all of you how we are applying this formula? Clear to everybody? Okay. Last is Bayes theorem. Now that Bay is different, which we all know, but this Bay is different. So this Bayes theorem says something opposite. It's ulta pulta. So what does it say? It says that generally suppose we have two bags. We have bag number 1, we have bag number 2. So if there is a question which says that there's a bag number 1, there's a bag number 2, you are taking out a ball. Okay, what is the chance that it is a red ball? Simple. What is the chance that it is a red ball? 3 out of 5. What is the chance that it is a red ball? 2 out of 6. That is simple. But what if they twist the question? If they say, what is the chance that it is a red ball? What is the chance that I have taken out a red ball? Okay, I have taken a red ball. What is the chance that it is from bag number 1? The question is now twisted. Now the question is not asking what is the chance of getting a red ball. It is saying that I know what is the chance of getting a red ball. I don't want to know that. I already have a red ball. I want to know what is the chance that this red ball is from bag 1. It is not from bag 2. So that is Bayes theorem. Bayes theorem basically says when you want to calculate something ulta, when you want to calculate something opposite, that what is the chance of getting a bag 1 when a red ball was chosen. So what will be the probability? It will be basically total probability formula will be used. Here you will do opposite. What opposite? Probability of getting a red ball given that this red ball has been chosen out from, probability of choosing bag number 1 multiplied with probability of choosing red ball given bag number 1 is chosen. Red ball given bag number 1 is chosen, and here you want to find out bag number 1 given red ball is chosen. So they are both opposites. So here Bayes theorem is used. Divided by total probability. Just now we learned how to calculate total probability. Let's do a question. I know you are very confused. Let's do one question. There are two bags. Okay, there is bag number 1, bag number 2. It contains 4 white balls, 3 red balls. It contains 3 white balls, 7 red balls. One ball is drawn at random from one of the bags and it is found to be a white ball. Find the probability that it is from bag 1. Again, they want to know which bag is used. They don't want to know what is the probability of getting a white ball. They already know that white ball is taken out. They want to know it is from bag 1 or bag 2. So we will use Bayes theorem. So first of all, let E1 be the event of choosing bag number 1, E2 be the event of choosing bag number 2, and A be the event of choosing a white ball. So first let's calculate what is the probability of choosing bag number 1? Half, because there are only 2 bags. So bag number 1, 1 by 2, bag number 2, 1 by 2, 1 by 2, 1 by 2. What is the probability of choosing white ball from bag 1? 4 out of 7. What is the probability of choosing white ball from bag number 2? 3 out of 10. And total 10 balls. Total 7 balls. Now simply put everything in the Bayes theorem. So probability of getting bag number 1 when white ball is chosen is probability of getting bag number 1 multiplied with probability of choosing a white ball given bag number 1 is chosen upon half into 4 by 7 plus half into 3 by 10. Just solve this and you get your answer. Alright, now these type of complex problems might not be asked in your exam, but it is not even that complex that it cannot be asked at all. It can be asked. Okay, that's why I'm making you understand each and every formula. So till now we have learned all the concepts related to probability. Now let's do previous year question paper based asked questions which were asked exactly in your KEAM exam in 2022, 2021, 2020. I'm using the recent papers because recent papers only matter. The old papers definitely keep changing their pattern. So let's look at the recent paper. Let's do a lot of questions. Okay, you solve along with me and let me know the answer in the comment section. I'll check. Alright, question number 1. There are 2 dices rolled together. Each die has 6 faces which are numbered 2, 3, 5, 7, 11, 13. So die number 1 is having 2, 3, 5, 7, 11, 13. Die number 2 is having 2, 3, 5, 7, 11, 13. What is the probability that sum of the numbers on the top faces is a prime number? First of all, how many total outcomes? Total outcomes are 6 into 6. 6 outcome in the first dice, 6 outcome in the second dice, 6 6 are 36 total outcomes. Now what is favorable outcome? When will you get prime number? So see, this combination is a prime number, 2 plus 3, 5. Then which combination? 5 plus 2, 7. This is also a prime number. Any other combination that you see here which can be prime? So let's see. 2 and 5 will be prime number. Similarly, this is like let me write it this way, okay? Die 1, die number 2. In the first dice, if you get 2, in the second you can get 5 because 2 plus 5 is 7. In the first dice you can get 5, in the second you can get 2. That is also one possibility. Now 2 5 can come, 5 2 can also come. So this is also possible. Any other combination we have? Let's see. 2 3. 2 plus 3 is 5. Similarly, 3 plus 2 is also 5. And which other combination can give us 11 plus 2? 11 plus 2. Okay, so 2 plus 11 is 13. 11 plus 2 is 13. So only these number are prime numbers. Others are not prime. 3 plus 7, 10. 7 plus 13, 20. They are not prime. They are composite numbers. So only these combinations are giving you prime number. So probability is favorable outcomes upon total outcome. So how many outcome in your favor? 1, 2, 3, 4, 5, 6. 6 outcome out of total. How many total? 36. So 6 out of 36. 6 1 is 6, 6 6 is 36. Answer is 1 by 6. Understood everybody? Next question. 3 fair dice are rolled simultaneously. Let ABC be the numbers on the top of the dice. What is the probability that the minimum of ABC is 6? First thing first. What will be your total probability here and what will be your favorable outcome here? So, since 3 dices are rolled simultaneously, okay, then the probability that the minimum of the 3 dice is 6. Now, we know that every dice will have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So, total there are 6 into 6 into 6. 216 outcomes. Now, in this, what is our favorable outcome? My favorable outcome is minimum of the 3 should be 6. Now, take any combination. Let's say I am taking a combination. In the first dice 5, in the second dice 6, in the third dice 1. What is the minimum value? 1. If you take 6, 5, 5. What is the minimum value? Smallest value? 5. So, in what situation you will get smallest value? 6. There is no number bigger than 6. There is no 7, 8, 9. So, there is only one outcome. 6, 6, 6. What is the minimum value? The minimum value is 6. There is no number smaller than 6 here. 6, 6, 6. Only in this outcome you are getting minimum value as 6. So, only one favorable outcome. So, our probability is 1 out of 216. Only one favorable outcome upon total outcomes. Clear? Next question. If A and B are 2 events such that probability of A is given, probability of B is given, probability of A intersection B is given, they want probability of A given A union B. First of all, what is A union B? A union B is A, probability of A plus probability of B minus probability of A intersection B. Just now I taught you this formula. Probability of A 0.5, probability of B 0.4, probability of A intersection B 0.2. 0.9 minus 0.2, 0.7. Now they are asking you probability of A given A union B. So it will be probability of A 0.5 given A union B is how much? 0.7. So basically decimal will be removed, you get 5/7. That is your answer. Option number C. Simple. Next, there are 37 men and 33 women in a party. If a prize is given to only one person chosen at random, the probability that the prize goes to a woman is so simple. Favorable outcome upon total outcome. Favorable outcome will be the prize should go to a woman. So how many favorable outcomes are there? 33 favorable outcomes because 33 women out of total is 37 plus 33. So this is 33 out of 70. Option number A. Right answer. This was so easy, so easy. Generally the question will be very easy level because there are lots of questions and very less time given. So of course there will be easy level questions, right? Next, a fair coin is tossed twice. Tossing a coin twice. Do you know what all outcomes are possible? Let me show you. If you toss two coins, head, 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 tail, 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 head. These are the only possible outcome. Is there any other possibility? No. Only these outcomes are possible. Okay. So the coin is tossed twice. Given that the first toss resulted in a head, what is the probability that the second toss would also result in head? So simple. First is a head, second is also a head. How many favorable outcome? Only one. There is no other outcome which is having head, head. There is only one outcome which has head, head. So the probability will be 1 out of 4. Option number B. है ना? There is only one head, head out of total. So 1/4. Clear? Next question. If A and B are two events such that probability of A is 0.2, B is 0.55, A intersection B is 0.1, then the probability of B intersection A complement. Now listen very carefully. What does this mean? B intersection A complement. It means probability of getting a B minus no chance of getting A. There should not be any chance of getting an A. So how can we calculate this probability? So you know the probability of B. Now B should come but A should not come. B should come but A should not come. So what I will do? Probability of B minus probability of A intersection B. Because if there is anything common between A and B, this will be eliminated. So when you eliminate anything common between A and B, only B is left. Only this part is left. And that is asked in the question. They are asking in the question, common between B and A complement. A complement means not A. So this will be 0.55 minus 0.1. So this will be 0.45. Which option? Option C. Right answer. Alright guys, now coming to I guess the last question of the day. Two dices are rolled. If A is the event that the sum of the number is 4, B is the event that at least one of the dice shows 3. What is the probability of A given B? Very good question. Very good question. First of all, you want to find out what is A. What is A? A is the event sum of the number is 4. So you are rolling two dice 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. When will you get sum of number as 4? If you get 1, 3 combination, if you get 3, 1 combination, or if you get 2, 2 combination. Is there any other combination which can give you 4? 1 plus 2 is 4? No. 1 plus 5 is 4? No. 6 plus 2 is 4? No. There is no combination possible. Only this combination is possible. Okay. So basically you have 3 out of 36. What is set B? Event B is at least one of the dice shows a 3. at least in one dice 3 should come. How many such outcomes are possible? There are a lot of outcomes possible. How come? At least in one 3 should come. So either 1 3, 2 3, 3 3, 4 3, 5 3, 6 3, right? Similarly, 3 1, 3 2, 3 4, 3 3 will not take because we have already taken 3 3, है ना? 3 5, 3 6. So total how many outcomes? 11 out of 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 36 are possible. Now they are asking you, what is the probability of A given B? What is conditional probability formula? A given B is probability of A intersection B upon probability of B. So first we need to find out what is A intersection B. From here itself, let me show you what is probability of A intersection B. Now, intersection means common. What is common between them? Show me. What is common between them? 1 3, 1 3, 3 1, 3 1, 2 2. There is no 2 2. There is no 2 2 here. So only these are common. Only two things are common. P A intersection B is 1 3 and 3 1. Only two things are common. So we have the formula. Hence, probability of A given B is probability of A intersection B upon probability of B. A intersection B, what is common between them? Only 2 out of 36. What is probability of B? 11 out of 36. 36 cancel. You get 2 out of 11. Option B is your right answer. Understood? Now this was a little complex question. You see, conditional probability formula were used. First you have to find out how many favorable outcome of A, how many favorable outcome of B, then how many favorable outcome of A intersection B. A intersection B is basically what is common between them. Common is 1 3 and 3 1. Only 2 are common between them. So 2 out of 36 are common. So A given B, what is conditional probability formula? A intersection B upon PB. A intersection B is 2 out of 36. PB is 11 out of 36. 36 cancel. 2 out of 11. Got it, everybody? Okay, so we have come to the chapter's end. We have seen each and every topic from the chapter, solved multiple types of questions related to each and every topic and previous year question as well. So I hope this session will be super useful to you. I have also made mind map of the formula sheet. So before your exam, you can revise this formula sheet and all the formulas will be right in front of your eyes. This is conditional probability formula. This is probability always lies between 0 and 1. This is multiplication theorem formula. Oh, this was properties of conditional probability and this is conditional probability. Then what if there are independent events, PE into PF? What if they are mutually exclusive? A intersection B will be 0. Total probability formula, which is also used in Bayes theorem formula. So all the formulas I have listed down here for your ease. Alright, so we have completed the chapter with probability basics, conditional probability, properties, multiplication theorem, mutually exclusive events, exhaustive events, independent events, total probability and Bayes theorem. So all the best for your KEAM exam. Subscribe to this channel if you want such lectures on each and every chapter of class 11th and class 12 maths. I will help you revise all the chapter and make you solve all the previous year questions as well. So do subscribe to the channel, like this video if you enjoyed today, and do let me know in the comment section that was this session useful for you or not. Thank you for joining in. Take care everybody. Bye bye.